have 9 people here. Okay, maybe I think we should start. Considering the time, we've been given limited time, and we have got a full house. We have got in total 7 presenters, including the keynote speaker. So I would like to thank everyone for attending this session, and I would like to welcome Professor Kazuo Matsura from Ehime University in Japan to talk about his research in the area of vortex clustering of compressible transitional flows as a keynote. It's all yours. Please, you can start sharing your screen.
Thank you, Mr. Chairperson and Professor Date. Can you see my slides?
Yes, we can.
Yeah. Hello, everyone. My name is Kazuo Matsura from Ehime University. Today, I'm going to talk about vertical point clustering for compressible transitional flows in gas turbine cascade as a keynote. And this study is on the separation of points belonging to vortices into the rational clusters, rational groups, in order to understand and analyze the evolution of vortex and its components. In this presentation, first I'm going to talk about research backgrounds and objectives. Then I will propose a novel hierarchical vortex clustering method and talk about the results. In the first part of this clustering method, I will first construct the unidirectional clustering. And after that, method to the omnidirectional clustering generalization. And after that, I will introduce the functional clustering from a little bit different point of view. And after constructing algorithm, I will apply this method to the industrial problems like gas turbine cascade flows. And finally, I will summarize my presentation. Transition and the turbulence is a very complicated phenomena. Here, I'm showing the DNS direct numerical simulation results of natural transition, K-regime natural transition, and bypass transition. And in this transition, the vortices are interacting with each other in a complicated manner. For example, in natural transition, lambda vortices are created, and auto generation of secondary vortices are produced after that. And then small vortices interact with each other, and then they become the boundary layer becomes turbulent after that. And the symmetric hairpin vortices are created in natural transition. In bypass transition, the hairpin vortices, unsymmetric hairpin vortices are created around low speed streaks and concentrated a region, separated concentrated regions are produced in the boundary layers. In industrial problems, the turbine flow becomes much more complex. Here, I'm showing the gas turbine cascade flows with different free stream turbines levels. The upper part is sound propagation, and the lower part is vortex structures in boundary layers. And when the free stream turbulence is 0%, spanwise vortices or discrete spanwise vortices are created. And when the free-stream turbulence is much larger, the bypass transition takes place on the suction side of the blade. And turbulence, fully turbulent regions are visible near the trailing edge on the suction side. In gas turbine cascades, stator-rotor dynamic stator-rotor interaction takes place. And in this case, the situation is much more difficult compared to the previous case, only rotor case, in the case of the only rotor. Here, these are the cascade, and the stator and the rotors are interacting with each other. And the wakes from the upstream stator and the free-stream turbulence interact with the boundary layers around the blade, and the turbulent region convects inside the boundary layer, propagates inside the boundary layers. And so a very complex vortex phenomena is observed in these cases. In order to in industry, like in gas turbines, it's necessary to understand what's happening inside the boundary layers in order to increase the performance of, for example, the turbine. And so in order to understand the boundary layers and the vortex dynamics, I previously proposed algorithmic exploration of the dominant local dynamics of the hairpin vortices. And in this method, the interior points of vortex based on the ice surfaces of the second invariance of the velocity gradient tensor are extracted from the field, and nearly central curve, central points are extracted based on that by averaging, doing averaging. Local neighborhood of a skeleton point, the central point, is generated, and in this space, the right-hand side terms of the Navier-Stokes equations are decomposed into no further decomposable terms, and the large absolute value terms are then obtained. And after that, the dominant terms contributing to the variation of the right-hand side terms of the Navier-Stokes equations are extracted. And through these procedures, the dominant local dynamics of hairpin vortices are algorithmically, mechanically extracted for the understanding and analysis of turbulent vortices. However, regarding the extraction of vortices inside the boundary point, extraction of points inside vortices, the points were not necessarily divided into the rational units, rational groups of vortices or vertical elements. So in order to fully understand, in order to selectively understand vortex dynamics, we need to separate. I think we can improve the method to decompose the points into the rational groups. And if we can do that, we can selectively understand the local dynamic process of vortex dynamics, and we can improve the method much more. So in this method, in this study, we developed a clustering method that can separate vortex clusters successfully and recognize them individually based on physical connectivity among point clouds. And this is the objective of the present study. The target flow for algorithmic algorithm construction is the laminar turbine transition, the K regime flow. And especially we focus on the late stage of transition. And here, I explain what I want to do in this study. This is the introductory target image of vortex clustering. From this computation, we can get these kind of vortices in turbine flows as a result of direct numerical simulations. And if we plot the distribution of omega x streamwise vorticity on a streamwise series of x planes, we get these kind of the plots. And we see the vortices are not necessarily uniform. They are concentrated, especially concentrated region, the continuous region of vortices in the flow. And we want to extract these specially connected and concentrated vertical regions and put ID numbers on them, and we want to investigate its specific vortices, the dynamics of the vortices. And in order to reduce the information of the vortices, we, in addition, want to put central curves on these structures and manage the information by putting these kind of ID numbers on the vortices. And here, we call this divided structure as the supercluster, and the central, we call the central curves as skeletons. Here, I'm showing the separated vortices near the wall, and these regions shows the separated vertical region separated from each other. And these thick curves show the skeletons. Here, more completely, I will explain the cluster members considered in this study. I propose the hierarchical clusters and the subset proposed in this study. We express these clusters as a P cluster. The P means proto, sub, and super, and hyper. And this P cluster is an appellation of hierarchical clusters in the unified manner. We propose these unified cluster members in this study. Here, I will explain the contents of the P cluster here. First, we extract the points belonging to the vertical regions, and we call it a point or protoclusters. And we categorize these points inside the vortices on a plane as clusters. And we also get central points of the cluster for constructing skeletons in the next process. And we stack these clusters in the streamwise or in some directions, and get a volumetric region of vertical points. And we also get the skeleton, which is a central curve of the volumetric clusters. And these members are extracted within the instantaneous flow fields. And if we track, if we include the time axis, we can get super clusters. That is the stacking of a cluster, super clusters in the time direction. And we also get, if we track the skeletons in the time axis, we also get skeleton time surface. Skeleton plots can be plotted as a, if the we plot the accumulation of skeletons in the time axis, we get skeleton time surface. And in addition to these regular cluster members, we consider subclusters, which are part of the cluster members. They consist of the partial points extracted from these regular cluster members. Here, I will construct the clustering procedure here. If the flow fields are constructed, consists of one-dimensional vortices, one-directional stacking of vortices is very effective to think about the dynamics of vortices. So first, we think about constructing unidirectional clustering. Now I will explain its procedure. On each jth plane, the region of large magnitude of streamwise vortices are divided into some clusters. We call the mesh points constituting the clusters, protoclusters, or the points. And correlation between each cluster on two successive jth and j+1th plane is evaluated. And in this process, we sometimes encounter between jth and j+1th plane, we sometimes encounter multiple correspondence that one cluster on the plane have two relationship, strong correlation with the clusters on the downstream plane. And we prevent this kind of multiple correspondence, and we divide the clusters, upstream clusters, into, in this case, two members, each of which has strong correlation, a single correlation with the downstream clusters. And we continue this kind of process, the division process to the upstream within a whole domain repeatedly. And we finally get single correspondent clusters within the whole field. And by doing that, we get the super cluster elements and its skeletons, vertical region, connected to vertical region, and its reduced representation of these vertical regions, which consists of the points. And if we plot the all skeletons obtained in these flows, we get this kind of super cluster skeletons. And these skeletons, as a validation, these clusters coincide with the vertical regions obtained initially from the safety results. These skeletons, red ribbons going through the middle of the vertical regions. So these red ribbons skeletons are successfully constructed as the connected the points inside the vertical regions, reduced order representation of these vortices. And if we plot the near wall vortices with magnitude greater than some threshold and its associated off wall vortices, we get these kind of results. Here, we have remarkable results regarding the structure of boundary layers. This open curve shows the positive omega x positive skeleton, and filled symbol shows the negative skeletons obtained from negative omega x. And in most cases, the pairing of vortices, vertical ribbons appear in these flows. Remarkable findings regarding the boundary layer structure. And if we plot, if we track in time the skeletons, we get these kind of surfaces, skeleton time surfaces. We can construct these surfaces, and we can understand and how the central locations of vortices move in flow field. When the vortices in the flow are nearly one-dimensional, the previous unidirectional clustering is very effective. But generally speaking, the vortices in turbulent flow have a multiple orientation. So we need to extend the unidirectional clustering to three-dimensional clustering algorithm. Two methods or extension methods can be considered. One is repeating the x-directional clustering algorithm in the y and z directions. And in addition to that, we can also consider the clustering based on the vortex axis. Regarding the first algorithm, here I'm showing how can we construct the omnidirectional three-directional clustering algorithm. In here, we take up an example of vortex rings. This is the surface of the vortex rings, and if we plot the vortex rings in by the point cloud, we can get this kind of figure. And if we choose omega x for the extraction of vertical points in the x direction clustering, we get this divided distribution of points. And if we get central curve regarding this region, we get these central skeletons in each regions. There is some near the boundary, we get some skeleton does not follow the central, strictly speaking, the skeleton does not follow the central locations of the region near the boundary. But anyway, the skeleton follow the central location in each clusters. And if we continue this process in XYZ directions, we get the 6 skeletons and 6 super clusters. We can reconstruct the original shape after doing each directional clustering. Here, I'm showing the result. Here, I can merge. If I merge these clusters, we can reproduce the original vortex rings. Anyway, we can apply this method to the hairpin transition flow field. And now I applied this method to the initial stage for the reconstruction of a hairpin vortices. This streamwise structure continuation of points shows the the result from the omega x algorithm. And this rib span-wise structure shows the result from the omega z algorithm. So by merging these clusters from respective directions, we can reproduce, reconstruct the original three-dimensional structure of vortices. Yeah, the second method is clustering based on the vortex axis. Here, I'm showing the proto clusters, which are the points belonging to vertical regions, and the clusters divided point clouds, and skeletons, the mean locations of these separated vortices. And we can view this clustering from a little bit different viewpoint. Here, I will introduce functional clustering. On each point, we can decompose the Navier-Stokes equations or vortice-related equations, and we can correct the dominant terms. We can evaluate the dominant terms at each point inside the vortices, and we can recollect the vertical points depending on the set of the dominant terms. These points have we can specially extract the points which share the same set of dominant terms, and by doing this kind of clustering, we call a functional clustering, we can understand the clusters from the mathematical standpoint. Now I'm applying the previous clustering method.
Matsuura,
yes.
Maybe 1 or 2 more minutes to
okay.
present.
Thank you very much.
So we will have 1 minute or 2 minutes at the end for the question. Thank you.
I see. I'm applying this clustering method to the industrial problems of gas turbine cascade. And we applied this method to the dynamic rotor state interaction flow field, and we get extraction vertical points. And we applied the clustering method to the boundary layers near the trailing edge on the section side, and we get the different clusters are shown in the different color. But of course, because there is a limitation on the number of color, different clusters are sometimes plotted in the same color. But anyway, we got separated clusters and separate vortices successfully by applying the previously constructed algorithm. Okay, I will summarize my presentation. A new hierarchical clustering method for volumetric vertical region is proposed. Point clouds in the vertical regions are extracted from instantaneous flow field using series of planes and are grouped between consecutive planes. Cross-sectional distribution of points are then stacked in a direction. Each group of extracted points identifiable as an individual entity that is referred to P cluster. The present method is applied to the industrial problem of gas turbine. Thank you very much.
Thank you very much, Professor Matsuura, for a very, very interesting presentation. And I'm very sure will be very useful for a lot of students as well as researchers who are present in this session. A very interesting approach that you have proposed.
Thank you very much.
Yes, within my group, I've got some few students working in design of turbines, not gas turbines though, in the area of water turbines, but this is an interesting approach which can also be applied and extended there. I can see the very relevant. So anyone from the audience, if you have any questions.
Excuse me, I do have a small question.
Sure, go ahead.
At what range of Reynolds number is this method applicable?
Reynolds number, it's applicable to infinity. Reynolds number of infinity. If
Okay.
we have sufficient resolution regarding the direct numerical simulation. But in actually, the direct numerical simulation is hampered by the Reynolds number 10 to the 6, I think, or 10 to the 7th recently using a huge supercomputer. And so, but anyway, in principle, this method is applicable to the Reynolds number of infinity if we can do the direct numerical simulation is a very, very high Reynolds number.
Thank you.
Thank you very much for the very practical question that you have asked. Any other questions? We're already at the time, so if there are no other questions, maybe we can start with our next presenter. But if you do have questions, please contact Professor Matsura by email. He will be, I'm very sure, happy to answer and collaborate. I think we should use this platform as an opportunity to start thinking about collaboration with each other. Okay.
Yes, we are open for. We want to do a collaboration. Yeah, with you.
Perfect. Thank you very much. Thank you. Very nice to hear that. Now, in this session, our next presenter is Mr. Thanaputra Sitayang. Yeah, and I understand that you're going to, because I can see there's a recording. Do you want me to play the recording, or you're going to present online, like a live one?
Both is fine. You can play the recording.
Okay, I will play the recording then. Just give me a second. Okay, can you please confirm you can see the screen?
Yes.
Yes. Okay. Now, once I start playing, just confirm whether you can hear the audio.
Good day, ladies and gentlemen. My name is Thermostat Operation.
Yes, I can hear the audio. Thank you.
Okay, so I'll just make a quick introduction. So our next presenter is Thanaputra Sitayang from KMUT, and he's going to present his research on thermomechanical analysis of radial turbine in stationary and transitional operation. Yeah.
Good day, ladies and gentlemen. My name is Thermostat Operation. I am a master student of TTGS Thailand in an exchange program with AWT University. Today, I will present you the publication of the title Thermomechanical Analysis of a Radial Turbine in Stationary and Transient Operation. First overview, I will introduce the background knowledge objective. Then I will show you the numerical model. Last, I will show you the result and conclusion. The objective of this publication is to investigate the necessity of the boundary conditions. Then we evaluate the behavior of the thermomechanical stress in the turbine components, and then we determine the effect of thermomechanical stress on mechanical performance. So in this publication, we will focus on the turbine side, and we use the thermoshock operation, which is the operation that the temperature abruptly changes from a very low to very high, or very high to very low. First, to calculate the stress, we have to evaluate the temperature field, and to do that, we use the conjugate heat transfer to calculate it. And you can see that we also model this blow-by flow and the cavity in this with the radiation. So we investigate these two boundary conditions. And the y plus is less than unity. We use k omega SST, and the mesh is undergoes mesh optimization. The governing equation, as you can see in the slide. After we evaluate the temperature field, we import it into FEA model to evaluate the stress. So first boundary condition that we investigate is the blow by flow. So you can see that it's affect the stress distribution at the back of the turbine, but the result of this effect is quite low, so it's not necessary to include this boundary condition. Also, for the cavity inside the turbine view, we also see that the radiation effect is very low and it have not much effect on the stress distribution, so this can be also be ignored. Then we evaluate the stress field in the steady state operation and pinpoint the 3 high stress zone. For first and second stress zone, this affect by the bottleneck effect. The bottleneck effect is when the area of heat flux transfer is abruptly changed from very large area to very small area, and it increase the heat transfer rate in that area. So it's create a different temperatures field, and this cause high stress. For point 3, it's affect by mechanical load more than thermal load. For volutes, we also pinpoint 3 high stress zone. The first point is at the tongue of the volute, and this affect by the temperature difference between two flow at the inlet and at the outlet. And also the geometry restrict the thermal expansion of this area, so it's quite hard for it to expand, and it's cause a stress, pretty much stress. For point 2 and point 3, this also affect by the bottleneck effect. As you can see, it have a very high temperature difference in this small area. For transient calculation, we pinpoint the 2 high stress zone, and for the first stress zone is at the blade area. This has affect by the high temperature difference due to the underdeveloped temperature field, and also with the vortex that happen to appear along the base band that induce the flow and make a difference in the heat flux transfer between solid and fluid. Also, at the back of the turbine view, the high stress zone point 2, we spot the vortex that cause a difference in this heat flux transfer, as you can see in the picture, and it's caused a high stress zone as well. For volutes, the high stress zone is quite similar to the steady state simulation. However, the magnitude is a lot higher. With this underdeveloped temperature field, is cause a very high temperature difference and make a high stress zone. For the tongue area, this tongue area have a store zone that get the fluid, store it inside and keep it there for some times. And with this underdeveloped temperature field, is make the high temperature difference in this area and make a magnitude a lot higher. In conclusion, the boundary conditions are investigated, and the behavior of the thermal shock in transient and steady state are investigated, and the effect of thermomechanical stress on the mechanical performance are determined. And for the further work, the effect of thermal radiation between heat shield and the bivouac backside should be investigated. The heat transfer coefficients in shaft area, which as of now is a constant value, should be temperature dependent. The calculation of heat transfer coefficients between the volutes and the environment should be investigated. As of now, it is a function of the Nusselt number. And this brings us to the end. Thank you very much for your attention, and I will try my best to answer all your questions.
Good morning, everyone. My name is Yong Yutang.
Sorry, I need to stop
I'm
sharing
from.
Okay. So thank you for your time. So if you have question,
Yeah. So thank you very much for that presentation. Very interesting work as well that you're doing. So I will open up the questions from the audience. Anyone from the audience who wants to ask questions? this is the best opportunity to ask questions, get any concepts cleared up. Always remember, there's no silly question. Always ask questions. That's the best way to learn. No questions from anyone else. I can see there's maybe we're already getting tired after lunch in Thailand, and here in Australia towards the evening, people are getting tired. Okay, so maybe I've got one question in terms of it's an interesting and very important piece of work where the thermal stresses in the material are very important in mechanical design of these machines. So what is your recommendation in terms of achieving minimum temperature gradients? Any special materials that can be used?
So to achieve minimum temperature gradients, but we cannot change the thermal shock condition because it's normally it's happen. So we can evaluate the geometry of our piece of components to make it easier for it to have a more distributed temperature field, or have less hotspot that make high stress occur.
So how about using materials which have got better conductivity?
Yes, that would be best, but I mean, normally we try to use the material that have a high conductivity all the time. So
yes.
Yeah.
Yeah, because it's not a simple problem as just a conductivity, but also it needs to be corrosion resistant, as well as high melting point. There's a lot of combination. Okay, good.
Yes.
Thank you very much for your presentation. We are 3 minutes ahead of time. If anyone else has got any questions, please go ahead and
maybe me for
yes.
like maybe I am a experienced guy, so how you validate your result?
I didn't mention in the presentation, but we have a test rig in the facility of our VTH University, and we run. We have 5 operation points that we can validate the battery condition of our simulation. And yeah, the battery condition is based on that test rig, and based on some is based on the calibration of the result. So yes.
Thank you.
Good. Thank you very much. So maybe we can start with our next presentation. So our next presenter is Dr. Jirapon Kawadiwa. Is that correct? Maybe the family name is not pronounced very well. Sorry for that. And she is going to present her research on performance evaluation of multi-megatron microwave rotary dryer for tom yum spice processing. I mean, that's very interesting. Right after the lunch break, you're talking about something very nice. Go ahead.
Okay. Can you hear me?
Yes, very well.
Okay, good afternoon, everyone. My name is Jirapon Kawadiwa. I'm come from Major University. Today, I would like to present about performance evaluation of multi-magneton microwave rotary dryer for tom yum spicy processing. Outline of presentation, introduction, material and method, result and discussion, and conclusion. Let's start with introduction. Thai spicy, curry paste, and herb industry could be greatly considered as one of the resourceful industry of the nation, since they have effectively strengthened and the Thai industry to be competitive on the international stage. Food dehydration process is an approach that transfers that from outside to the food in order to remove the moisture and water. The resulting dry foods will inhibit microbial, decrease enzymatic activity, and chemical reaction that cause the transpiration and storage room temperature qualification will be invented because of the lower weight and better clarity after dehydration. Microwave drying is one of the modern and recent technology in heating of the foods at a low temperature. This leads to high quality product which could perfectly keep the product color, texture, and flavor. Compared with the typical hot air drying process, microwave dehydration has twice or 3 times better energy efficiency because the electromagnetic field could penetrate through the object issue and the heat could spread evenly in all surface and inside the object. In this, the research study, multi-magneton microwave rotary dryer was introduced in order to investigate the efficiency of limiting heat of dryer. The dryer was used from the drying garland gas, lemon gas, kaffir lime leaf, and chili. Initial moisture content of the sample was usually greater than 50% diabasis, and the final moisture content should be less than 14% diabasis. Multi-magneton microwave rotary dryer consider of 4 main elements. First part, drying chamber. The maximum of capacity is around 20 kg, but in the test only 10 kg was used. Microwave magneton is a main source of the 45.2 GHz power to the run system, power and control and display. In the performance test, 2 magneton were automatically switched on the every 30 minutes. This was because a prolonged continuous operation caused overheat the magneton. The research focused on analyzing microwave rotary dryer compared with drying process by using greenhouse solar dryer from the community enterprise. On the table 1 shows the initial metal content of the raw material. Result and discussion. The target final moisture content of the dry products must be less than 14% diabasis. The rotation speed of the dryer was adjusted to 20 revolutions per minute. The testing is found that the drying process from the garland leaf by using microwave rotary dryer has the shortest drying time, which allows in 5 hours. According to this device, outcome of the drying time, it could be obviously seen that the magneton microwave rotary dryer could reduce drying time of tom yum spicy by around 18 to 19% compared with the traditional hot air drying. The traditional hot air dryer was from the greenhouse solar dryer found in the community enterprise, and the shorter processing time was because the microwave energy can enter the moist material in the form of electromagnetic radiation and induce a large amount of water vapor form inside, which adds still to drying rate significantly. One of the important parameters explored during the drying system development was the curve of moisture loss of drying candidate can show in figure 2. The moisture ratio was found when during the drying as different conditions. It was found that drying rates of the galangal, lemongrass, kaffir leaf, and chili was the ideal because of the high moisture content in Tom Yum spicy and the rapid transpiration at the beginning of the process. In addition, the high humidity could easily help release the water in the Tom Yum spicy to the surface within the short period of time. Energy consumption was it of the most important indicator taken into the consideration when assessing the efficiency of specific technology process. Table 3 shows the energy consumption in terms of heat equivalent. It was found that Gallagher indicated the low energy consumption around 8.40 megajoule per kilogram water evaporation. The table 4 shows the shade of color characteristics between spicy ingredient obtained from the commercial community enterprise and this equivalent. The most products seem to have similar color characteristics. Analysis results of the dry sample from the different drying process are present in table 5. In terms of the water activity in range of 0 to 0.55, it has very significant impact of the cross of different biological processes, such as the rebuild of the microorganism, the high water activity, the high water activity are such as is what are the commonly assessed that below 0.6, that's the goal of the microorganism water completely inhabited. Therefore, above this value, the food product were more susceptible of quality. Conclusion: based on the research, blending microwave proves to be the successful in applying to Tom Yum spicy drying. The microwave rotary dryer used here the cost reduce drying time of the Tom Yum spicy by around 80 to 90% compared with the existing hot air dryer. Another would like to thank the Thailand Science Research and Innovation Office and School of Renewable Energy, Major University, Thailand. Thank you for attention.
Thank you very much for your very nice presentation. Maybe just hang on to the slides because maybe audience might have some questions. Okay, so we are opening this session for questions. Anyone has got any questions? Yeah, there was some noise. Anyone has any questions? For Jirapon? No? Maybe I will ask one question while others, they can think and come up with very good questions. Okay, so in your conclusion slide, you have shown that the time is reduced by around 80% in the reduction in time. That's very interesting. My question is, have you seen if there was any change in the taste between the solar dried and microwave dried?
That is my question.
Oh, sorry for that.
It's okay.
Taste is similar.
How many people you let them taste, like only you or
around 10 people from the community enterprise.
Do they have like the practical technique to taste the taste of that food? like a methodology to analyze the test one. Like it's delicious or something like that. I don't know. I think.
Yes, delicious.
Usually, they would have a panel of experts, those that are experienced with the food, to do like many people and then come up with consensus to say that it's actually very good. So I think for Dr. Jiraporn work, they are close to something like that too.
So others from the audience, have you come up with some questions? Because that this general question was just to give you some opportunity to think and come up with any interesting questions, any doubts you might have, or if you want to express your interest to collaborate with Dr. Jiraporn. No? Remember, always when you attend conferences, I mean, especially students, academics, we do collaborate, but students who are attending at present, I think you should take this opportunity and use it. If not this conference, next conference, I think you must use it to collaborate. I'm very sure if we were in Thailand presenting face-to-face in group, Dr. Jiraporn would have brought some samples.
Yes.
Yeah.
with Tom Yum testing.
Okay, maybe one technical question, Dr. Jiraporn. Have you done any investigation or analysis on energy consumption between solar dried and microwave? I'm assuming the microwave will be driven by solar PV, solar photovoltaic, but still maybe some kind of an energy analysis comparison. Have you done that? Are you on mute?
Again, please. Okay.
Any energy analysis between solar dry and microwave drying? So the amount of energy, solar energy radiated in this greenhouse, for example, you showed some greenhouse, you have to let it for maybe 2 days or 3 days for drying. So the amount of solar radiation you receive to dry maybe a kilogram of this spice. And then the amount of energy required to dry a kilogram of spice using microwave. If you haven't done it, maybe that will be something I would be interested in helping you out do that research. Okay, so good. Thank you. So maybe we can start with, we are running 3 minutes ahead of our scheduled time, so that's very good. Always nice. We have got our next presenter, Mr. Naruful Janviruch.
Yes.
Good. And is going to present. He's going to present with performance analysis of a laboratory monoethanoline based carbon adsorption and stripping setup. Go ahead, all yours.
Hello everyone, my name is Narupon Javilat. I am a memo power plant operator engineer and a master degree student at Chiang Mai University. Today I would like to present you my work. It is performance analysis of a laboratory monoethanolamine based carbon absorption and stripping setup. And this is my outline. I will start with the introduction. Today, the average temperature of the Earth's surface has increased by about 1 degree Celsius compared to 100 years ago. The IPCC report by the end of 21st century or the next 100 years, the average temperature of the Earth's surface could rise by 6 degrees Celsius. The rising rate is very fast. The melting of polar ice seems to be most affected by global warming. The Electricity Generating Authority of Thailand, or ICEP, is the largest power producer in Thailand. Myanmar Power Plant is the largest coal-fired power plant in Thailand. The Myanmar Power Plant releases about 16.8 million tons of carbon dioxide per year. Therefore, Myanmar Power Plant would like to study the technology used to capture carbon dioxide before releasing it into the atmosphere. And this video will show you how the carbon capture works. Okay, and next I will be talking about the objective of my work. This is the picture of the Myanmar Unit 12. This slide shows the full gas composition value at the Myanmar Unit 12. The carbon dioxide is 15.3%. So this research aims to set up and carry out performance testing of laboratory carbon capture system, including absorber and stripper, for treating the gas with similar conditions to the Myanmar power plant full gas. An aqueous solution of 30% MEA is a standard solvent used in the actual CO2 capture plant was utilized. Next, I will talking about the methodology. And this is my carbon capture laboratory scale schematic diagram. It's consisting of the gas feed set on the left side. The gas feed will feed the gas to the absorber for capture the CO2. After capture, it will pump the leach solvent to the stripper for separate the CO2 from the solvent. This is the kinetic reaction in the absorber. And this is the kinetic reaction in the stripper. This is the picture of my carbon capture laboratory scale. The left picture is the absorber and the stripper, and the pump and the heater. The right picture is the gas feed. From nitrogen cylinder and CO2 cylinder. This graph is my previous study. It shows the variation of CO2 capture efficiency with the different packing height and lead CO2 loading. From this experiment, it was found that the efficiency was between 95 to 96.7% at the full packing height. The higher CO2 loading led to reduction in capture efficiency. For the effect of the packing height, the capture efficiency was reduced markedly when the packing height was decreased from the 100% of packing height to 75% and to 50%. This is the experimental test condition and procedure. The experiment is test to determine the capture efficiency and the regeneration energy in stepper. It consists of 6 experiments to find out the effect of 2 variables, the lean CO2 and the regeneration temp. Next, I will talking about the results and discussion. From the experiment, it was found that carbon capture efficiency was between 96.2 to 97.1% as the fixed absorber temperature of 60 degrees Celsius. The higher CO2 loading led to an increase in carbon capture efficiency, and the higher regeneration temp appear to have slightly better CO2 capture efficiency. Okay, and this graph will show the regeneration energy is required to release the CO2. It was found that the regeneration energy required was between 5.4 to 7.1 megajoule per kilogram CO2. The energy required was lower at regeneration temp of 110 degrees Celsius than 120 degrees Celsius. The best condition of our experiment was 0.33 lean CO2 loading at the 110 degrees Celsius regeneration temperature. And the last graph will show the iron concentration in the lean MEA solvent after we operate the MyRap volatility scale. They were expected to come from the stainless steel T04. It's used in the absorber and the stepper column. It was shown that the iron concentration in the solvent increased with how of operation, but its concentration remained relatively low in the range of sub 10 ppm. So this material is suitable for CCS piping system. Okay, and the last I will talking about the conclusion. In this work, a laboratory scale CCS setup was assembled and tested. A conceptual study was carried out in a laboratory scale for CO2 absorption and steeping process by using aqueous monoethanolamine solution. From the experiment, the capture efficiency was found to be acceptably high, but the thermal energy required to regenerate the solvent was quite expensive. Nonetheless, post-combustion carbon capture seemed to be promising technology for EGAT mammal power plant. Amine-based absorption of carbon dioxide appeared to be robust and useful for subsequent testing. And I will thank you for support from EGAT and Chiang Mai University. And thank you for your attention.
Okay, thank you very much. Thank you very much for very good presentation. Now we are open for questions from the audience. I hope you're getting encouraged. No? No one is still encouraged? Maybe then we have to make a rule that the next presenter must ask a question.
Maybe me. Yes. Yeah.
Yes, go ahead.
I would like to know what the next for the carbon dioxide that capture. What is the next process for it?
When the carbon dioxide released from the solvent, I release to the atmosphere. In the if the carbon capture process, they will compress to the liquid and take them and transport them to storage somewhere. But in my lab, I release it to the atmosphere.
So maybe have you explored any other chemical processes where the carbon dioxide which is captured and stored can be then, instead of storing it in a liquid form, which requires very low temperatures, very high pressures, could be stored in a solid form in kind of an adsorbed, because you are using your monoethanolamine for adsorption in a similar fashion. Are there any other materials which are available in nature very cheaply, abundantly, that can adsorb, or chemical with a chemical reaction? It doesn't need to be surface adsorption. It can be a chemical reaction. Have you done any research on that? No? No. Okay.
No, we have not. But the setup that we have developed will be available so that the EGAT team and engineer can test their choice of chemical later on. I'm sure with added equipment.
Yeah, maybe what you could do just out of work, do a lot of work in water treatment, and one of the components, major components in salt water, is calcium chloride, and which is a big thing in terms of scale formation. So if you bubble the CO2 through that water, it forms into calcium carbonate, which settles, precipitates, and the scaling effect on heat exchangers is reduced. So fouling is reduced. So
very interesting. Yes. Because some of EGAT facility would be in the south and in the eastern part as well, where it is near to the sea.
Yeah.
Yeah, because the current setup is in the north. It's something like 800 kilometers away from seawater. But it's a good idea. Yeah, thank you.
I think always look at as because you said you're a master's student going forward, working maybe in the industry or doing PhD. Look at how at CO2 as a resource, how that resource can be used to generate another resource. Because calcium carbonate is also very useful in industry, in pharmaceutical, a lot of places.
Yes, yes, very
Okay.
interesting.
Any other students? No, I think maybe now we are back on time. So maybe no. If you have any questions, please ask Narufal through emails, and he will be most happy, I'm very sure, to reply to any questions.
And I will have to jump to other room.
Yes.
Thank you.
Thank you. Okay, our next presenter is Mr. Abhishek Gupta, and he is going to present his research on optimization of source sink matching for CCS and the ultra mega Indian power plants. Yeah, we can see your screen, but we cannot see you as a presenter. Do you want to turn on your camera? Or
hello everyone.
Yeah, we can see you. Okay, good. And we can hear you as well.
My name is Abhishek Gupta. I am here to present my paper titled Optimization of Source Sink Matching for CCS Ready Ultra Mega Indian Power Plant. As you can, the worldwide CO2 emission are increasing rapidly. We can see from the right figure that the historical increment of CO2 emission from top 5 emitting countries. India stands third in the after China and USA with around 2,400 million tons CO2 emission per year. From the left figure, we can see if everything is going as per stated policy scenario, the CO2 emission will lead to global temperature rise about 2.5 degrees Celsius in 2050. The CO2 emission needs to be reduced by 50% by 2050 to check the temperature rise within 2 degrees Celsius. The figure shows different scenario and to limit the temperature rise, of which net zero by 2050 is able to control the temperature rise up to 1.5 degrees Celsius, which is recommended by IPCC. This scenario involves various technologies such as zero carbon buildings, low emission from heavy industries, solar and wind energy, energy efficiency, and phasing out of fossil fuel power plants. It also involves carbon capture and storage. The carbon capture and storage or carbon capture and sequestration prevents large amount of CO2 from being released into the atmosphere. The technology involves capturing CO2 produced by large plants and then compression it for transportation purpose, then injection into the deep rock formation with a carefully selected and safe site. The CO2 storage options are mainly deep saline aquifers, depleted oil and gas reservoirs, salt bed and unminable coal beds. India has committed to reduce greenhouse gas emissions by 33 to 35% by the year of 2030 and has declared to shift to supercritical thermal power plants, which have high efficiency and which reduces emissions very much from the subcritical power plants. The addition of 100 gigawatt of power capacity has been planned by the year of 2040, which is mostly based on supercritical technology. The Ministry of Power has planned 16 supercritical technology based ultra mega power plants known as UMPPs, having 4,000 megawatt generation plant per each. Because CCS can achieve significant CO2 emission, it is considered a key option to reduce greenhouse gas emission. The data shows carbon sequestration potential in India, which is estimated as 500 to 800 gigaton of CO2 total. Here, from 16 UMPP planned, some are cancelled due to various environmental, regional, and sociological reasons. 7 UMPPs have been selected in this study, in which 2 are in operational stage and others are in different stage of planning. Because the location The location and details are given here. Each plant having 4,000 megawatt capacity is generating 23.2 million ton of CO2 per year, in which 20.85 million tons, around 90% of CO2, can be captured annually with the help of CCS. The location of basin and aquifer has been adopted from Holloway et al. And DGH website. The sourcing matching has been done using multi-objective linear problem technique with minimum cost of CO2 storage and maximum amount of CO2 storage. The environmental assessment and economic assessment is done as per ISO 14,000 code and NETL report 2017. The figure shows the system boundary of the problem. There are several assumptions taken in this study which are based on literature. The UMPPs are based on supercritical pyrolyzed coal combustion technology. The efficiency of CO2 capture has been taken as 90%. The pipeline transportation has been used for CO2 transportation. Lifetime of power plants has been selected as 40 years. The power load factor has been considered as 85%. The maximum distance for pipeline transportation is taken as 1000 kilometers. In the matching process, first oil and gas fields are preferred due to their security and economic potential. After that, saline aquifers are preferred. In the results, first one is sourcing matching of power plants to their respective storage basin. The basin map is adopted from DGH website and the UMPPs has been allotted on the basis of minimum distance from the basin. Krishna Godavari basin, Mahanadi basin, Kutch basin and Kaveri basin have been selected as they have large CO2 storage potential and nearer to the UMPPs. The Vaderevu and Sasan UMPP have been matched with Krishna Godavari basin and Bihar UMPP, Devghar UMPP and Sundargarh UMPP have been matched with Mahanadi basis and the Cheyur UMPP has been matched with Kaveri basin. The Tata Mundra, which is operational, is matched with Kutch basin to store their emitted CO2. The next result shows the environmental assessment of a UMPP. As every plant has same capacity as 4,000 megawatt, the environment assessment has been done for one plant and considered as same for each. The figure shows annual emission from a UMPP with and without CCS. It shows 87.3% reduction in CO2 emissions when CCS is implied, and other emission such as sulfur oxides, NOx, and particulate matter are already controlled in a UMPP, so they show no difference between these plants with and without CO2. The next result is economic assessment. So in which for every power plant, for the case of carbon capture, the plant for each plant is showing similar capital cost and operating cost. However, CO2 transportation cost for each plant will be different. The figure shows the increment of cost due to CCS. The capital cost is increased by 80% and the annual operating and maintenance cost is increased by 66%. The CO2 storage cost for each plant is same because there is same amount of CO2 to be stored. To conclude the study, we can say that CCS can significantly reduce the CO2 footprint. The role of CCS goes beyond a clean coal technology. A total of 5.83 gigaton of CO2 can be captured from selected power plants in their lifetime with 145.75 million ton of CO2 in a year. The major challenge in implementation is the cost of CCS. With 80% increase in capital cost and 66% increase in annual cost, the funding for CCS should be addressed properly before that for employing these technologies. These are my references. Thank you.
Thank you very much for very eye-opening presentation. The numbers that you have shown, they are really mind-boggling. The large amount of carbon dioxide that is generated and the large amount of power that is getting produced at those power plants, and the cost as well it's really very high cost. So have you thought about any other way of reducing the carbon emission. So I can see you've done the matching.
There are
And
various technologies
Mm.
in the scenario net zero up to 2050, that low carbon, zero carbon buildings, minimize CO2 emission from with the help of solar and wind energy, but these are not enough.
Mm.
Because CCS plays an important role in these scenarios only.
Mm.
We cannot fully get that 1.5 degrees Celsius temperature rise up to 2050 or even 2100 as
Okay.
this next scenario, this stated policies. So we need CCS to imply. The cost factor is a major challenge, but
Mm.
here
Good. Any other audience wants to ask questions? Is that's not just a challenge for the part of the world, I mean, for India, but similar challenges are present in most of the other countries.
yes, most of them.
So anyone else who wants to ask any questions, or does that raise any concerns in your mind? Yes.
Abhishek.
Yeah.
Yes.
You are talking about carbon capture and sequestration, which is the one major hindrance to implement this CCS is its cost. The cost to implement this technology, and technology is not cost effective. So is there any other cost effective methods to sequester the carbon?
Yes, sir.
There are many
You can see
related
from
to
there are many options CO2
capture.
storage. But yes, the deep saline and deep saline aquifer is
focusing
based,
on the sequestration. I'm focusing on
Yes.
sequestration. Apart from
yes,
what
where
you are
yes,
proposing, apart from that,
yes,
is there any
CO2
other viable alternative?
for sequestration there are many industries which use CO2 as a base product or raw material to produce various product. Also in oil industry, in oil reservoirs, CO2 can be used for enhanced oil recovery, so that there are some economical output, because some amount of oil remains in the reservoir which cannot be take out easily. With the help of CO2 sequestration, it can extract from these reservoirs the oil and gases.
Good.
And there are
That was a
also
very interesting
methane.
question. Yes, and that was a very interesting question, and the answer from you is, I just want to extension to that same question. If you go back to the cost graphs, please. So you've shown this very high cost of capital. Now, can you please explain if that highest capital cost is to establish the pipelines over that 1,000 kilometers or a few hundreds of kilometers? Is that the major cost?
The major cost is capital cost only.
Yeah, capital in what sense? I mean, the
Capital
plant is still
cost
the same.
No, the plant is still the same, but the cost of retrofitting the capture technique, capture methodology to the plant, because the carbon capture techniques, it involves various infrastructure needs to be built within the power plant, and the CO2 capture system and the compression system. The cost of retrofitting is the major portion. After that, CO2 storage and CO2 transportation cost, because the pipeline cost are based on distances from basin. So we have selected only 1,000 kilometers for.
Yeah, and so
for
the
the basic of
transportation
transportation
cost is really the capital cost required to build the transportation infrastructure, and not the
Infrastructure and
operational
running.
cost to pump the CO2 ongoing during the once. So that cost is not the operational cost. Okay, good, very interesting, and there's a lot of work that needs to be done, definitely, not just by academics. I mean, researchers, we can't do much. Industry has to do a big part, play a big part, and the governments, they have to play a very huge part in this. And what's happened over in last couple of weeks in COP20, the recent climate summit. It
Yes,
wasn't
26.
very helpful. I personally believe it should have been, everyone should have targeted a lot more. Anyway, what we are doing something. So our next presenter, thank you very much for your
Okay.
presentation, Abhishek. Our next presenter is Chenpat Patnaputra. Yes, good, you're there. And he's going to present his research on effects of remaining turn numbers on maximum heat flux on a rotating close couple pulsating heat pipe integrated on energy conversion devices. Very interesting. I'm looking forward. Maybe just before you start, yes, I wanted to see the name of the authors. So Pradit is your supervisor. Good. I wanted to see if in Chiang Mai, if Pradit is contributing. Is he going to join us today? I don't know whether he's there. Okay, all yours.
Good afternoon, everyone. My name is Chinpat Patnaputra. Today, I will present about the effects of rolling turns numbers on maximum heat flux operating cold loop pulsing heat pipe integrated on energy conversion device. Rotating machines or device which have a rotating motion, for example, the steam turbines and disc brake. When these devices are in rotating motion, heat generated and increased at the contact surface area. For example, in case of disc brake, we get the high temperatures when it's skin touch between brake pad and brake disc. The high temperatures can be affect brake pad to be burned, and the efficiencies of braking will also be decreased. Therefore, we have to install the heat pipe for cooling by using the rotating cold loop pulsing heat pipe. This method does not be used the external energy and also can be applied to the heat recovery. The normal operating state of the rotating cold loop pulsing heat pipe, the working fluid is circulated with the slug flow patterns. We have the vapor core alternated with the liquid slug. However, when the heat pipe of the normal operating receive the high heat flux, the working fluid will insufficient for heat transfer in evaporator section, dry out and diapatch occur inside the tube on the surface of evaporator section. This operating condition is called critical state, and the heat flux with the rotating cold loop pulsing heat pipe can increase it to critical state. The heat pipe will not be able to transfer heat, and heat pipe can be damaged if the operated for long periods of time. So it is necessary to study about the critical state of rotating cold loop pulsing heat pipe. One of the main parameters of the thermal performance and maximum heat flux is the number of rolling turns. When the rolling turns increased, the surface area and number of nucleation size was increased. However, the pressure drop was also increased. Moreover, the number of rolling turns that affects to the maximum heat flux of the rotating cold loop pulsing heat pipe has not been studied before. Therefore, this variable is necessary to be studied. And this is the objective of this study. The first is analyze the inside phenomena of critical state of rotating cold loop pulsing heat pipe. And the second is study the effects of the number of rolling turns on the maximum heat flux of rotating cold loop pulsing heat pipe. And this is a combination of the rotating cold loop pulsing heat pipe set. The thermocouple was installed at the condenser and evaporator sections in every turn of the heat pipe. The heat pipe is sandwiched by annular heater to heat the heat pipe and insulated to minimize the heat loss by the insulating sheet. And the outer part is the steel cross frame. And this is the components of the laboratory setup. In the experiment started from control the rotating speed of the heat pipe by DC motor. After that, increased in the heat input to 20 watts per step from the heater controller. when the rotating cold loop pulsing heat pipe was operated in the critical state, the maximum heat flux was recorded. And the conditions of critical state of rotating cold loop pulsing heat pipe have 3 conditions as defined in the green frame. For the results of this experiment, I will describe about the phenomena of rotating cold loop pulsing heat pipe in the critical state. For analysis of the phenomena inside the rotating cold loop pulsing heat pipe, I will describe 2 step by step using an example from the experiment case of the heat pipe which have the 33 turns and use the water as the working fluid. When the heat input was increased from 120 to 280 watts, it found that the frequency and amplitude of temperatures of the evaporator and condenser section increased. The working fluid was circulating in slug flow patterns, so the rotating cold loop pulsing heat pipe was operated in the normal operating state. When the heat input increased to 320 watts, the frequencies of the evaporator section temperatures was very high with a very low amplitude. This implies that the working fluid has very high flow velocity and the internal flow patterns of working fluid was changed from slug to annular flow patterns. This annular flow patterns has only thin liquid cover inside the heat pipe, so this flow patterns is very high risk for die out. The heat pipe remained in the normal operating state. From the pictures can be observed that when the increased the heat in the next step, the heat pipe was raised to the critical state. So this state was just before critical state. When the heat input increased to 340 watts, the temperatures of condenser section was decreased. This implied that the heat pipe could not transfer the heat from the evaporator to condenser section. Dry patch was occurred inside the evaporator section. The thermal resistance clearly highly increased. Heat throughput decreased from 302 watts to 288 watts. So this characteristic could be identified that the heat pipe was raised to the critical state. The maximum heat throughput was 302 watts, and the maximum heat flux was 16.37 kilowatt per unit area. And this is the result from the effects of number of marine turns on the maximum heat flux of rotating cold loop pulsing heat pipe. From the experiments, it found that when the marine turns number increases from 11 to 33 turns, the maximum heat throughput increased in both case of R123 and water. When the marine turns number increased, number of nucleation sites increased, driving force of the heat pipe was increased too. However, the increased rate of pressure drop was higher than the driving force. The internal flow pattern was difficult to change from slug flow to annular flow. Therefore, the critical state of the heat pipe is more difficult to occur. However, from the experiment show that the rate of increase in the maximum heat throughput was less than the rate of increase in the heating area in evaporator section. So when the marine turns number increased, the maximum heat flux decreased. And conclusions of this experiment is that when the rotating cold loop pulsing heat pipe in normal operating was received the high heat input, the working fluid inside heat pipe was increased circulating velocity and changed the flow patterns from slug to annular flow. This annular flow pattern is very high risk for die out. So when increased, the heat input die out was occurred inside the heat pipe, and the rotating cold loop pulsing heat pipe was operated in the critical state. And when the number of marine turns was increased, the maximum heat flux was decreased. So this study will provide an important basics of the conditions of the critical in the rotating cold loop processing heat pipe. This can be improved for cooling the rotating motion device in practical. The presented work is financially supported by the Thailand Research Fund, Engineer Thailand, Heat Pipe and Heat System Laboratory, Department of Mechanical Engineering, Factory of Engineering, Chiang Mai University, Thailand. Thank you for your attention. Do you have any question?
Thank you very much, Jinpan. Very interesting presentation. Now, any questions from the audience? No questions from the audience? Maybe let me ask you a question. It's a very interesting work on pulsating rotating heat pipes. Now, maybe I missed it, but all the results you showed, were they just for stationary condition or actually the heat pipe was rotating?
Yes.
And what was the RPM? So what's the relationship between the speed, rotational speed, and the heat flux? Is there any relationship between the speed and the heat flux? If the speed was increased, or you did not do any tests on different speeds?
In my experiment, in this, I don't change for of the speed of rotating. I fix
Okay.
in
So the results that you showed was what at what RPM? Rotational speed was how much?
About 220 RPM.
Okay. And okay, so based on your experience so far doing this project, what do you think? Do you think the rotational speed will have significant effect on the performance of the heat pipe? What do you think?
Yes, this is effect. When the rotating have the more high speed of rotating, the heat pipe can rest to the critical state easier.
And so do you have any suggestions or any thoughts about how can you address this problem? How can you solve this problem at higher rotational speeds?
I think when you have the high rotating speed, you can train the physical of the heat pipe. You can increase the diameter of heat pipe. It can help.
Okay, good work. Very interesting. Now we still have 2 more minutes. Just I want to bring to your attention, I mean, your supervisor, Freddy Tatun, he knows about the work that we are doing here at RMIT as well. A very good friend of mine. And in 2023, so 2023, so in 2 years' time, in February, we are organizing a conference in Melbourne, International Heat Pipe Conference and Heat Pipe Symposium. So you're most welcome to participate in that conference. Okay, good. So no other questions? Any other questions from anyone else? No? Okay, thank you very much for the presentation. Now we'll go to our last presenter, Mr. Hong-Si Su. Is he here?
Here.
Yeah.
Yes.
Good. So if you can share your screen and you can start presenting, let me introduce you. So Mr. Hong-Si Su is going to present his research on novel 2-step process for hydrogen production from waste plastic with low operating temperatures. Very interesting as well. Good.
Okay. Okay, you hear me?
Yeah, we can.
Good afternoon, everyone. I'm from Zhejiang University, China. I'm very pleased to participate in this international conference. The topic of my presentation is a novel 2-step process for hydrogen production from waste plastic with low operating temperature. Professor Wang is the corresponding author of this study, and I'm the speaker, Hong Tai Su. So I will introduce this research to you from this point. Plastic pollution has become one of the major environmental problems in the world. The plastic production in China accounts for about 30% of the world's total plastic production. In 2019 years, more than 63 million tons of waste plastic was produced in China. Traditional plastic disposal methods are mainly based on incineration and landfill. But these two methods cause serious secondary pollution. Therefore, it's necessary to develop advanced technologies to realize the clean disposal of waste plastic. At present, the thermochemical conversion of polyolefin waste plastic is mainly based on pyrolysis and reforming. This technology can realize the high efficiency conversion and the disposal of polyolefin plastic, but high reaction temperature and energy consumption significantly affect the development of this technology. Compared with pyrolysis, hydrothermal conversion can greatly reduce the reaction temperature. However, the supercritical water gasification of waste plastic is also limited by its harsh reaction conditions. Based on the hydrothermal conversion, aqueous phase reforming can convert organic matter into hydrogen under lower reaction temperature and reaction pressure. Here we can call air phase reforming APR. However, the materials of APR technology is mainly for oxygen-containing hydrocarbon organic matter. So the conversion of oxygen-free plastic into oxygen-containing hydrocarbon organics is one of the main problems. Therefore, we intend to develop a plastic hydrogen production process under low temperature hydrothermal system. In order to solve this problem, we developed the two-step process of male hydrothermal oxidation and the catalytic reforming for with polyolefin plastic such as PE. This process can realize the efficient disposal and the conversion of PE waste plastic below 260 degrees. Firstly, the oxidation pretreatment of PE waste was conducted in a low concentration hydroperoxide solution. And the hydrogen, the peroxide can destroy the carbon bonds of launching in PE through the selectively oxidation. And oxidize the PE into small molecular organic acid, mainly composed of the acetic acid. So it is suitable for APR. The results show that the oxidation process has over-oxidation, which produces the CO2. So this is the first step. So next step, in the second step, the small molecular organic acid produced by the first step was subjected into the catalytic APR under the Rotational catalyst. And the results show that the hydrogen peroxide can effectively reduce the over-oxidation in the hydrothermal oxidation process of PE and obtain the highest hydrogen yield with the concentration of 0.5% diluted hydrogen peroxide. So you can see the figure. The 1 kilogram of the PE can generate 22 grams of the hydrogen. Because this is the new technology, so I think the hydrogen yield is not very high. So we try to develop the new catalyst for improve the hydrogen yield. In addition, we conduct comparative experiments on the low density PE and the high density PE under the same operating conditions. So LDPE has a higher hydrogen yield. This is due to the fact of the structure of HDPE is mostly launching. So you can see the right figure. Compare with but in the LDPE, the degree of the breaching of the short chain is higher. So compare with the HDPE in the first step, LDPE is easier to organize and convert in hydrodermal pretreatment. As we know, the ruthenium and the nickel metal catalysts have a silent catalytic effect on the carbon bond breaking. In order to optimize the reforming process and reduce the catalytic cost, we prepared the ruthenium and the nickel bimetanic catalyst and study their catalytic performance. And the results show that the monometanic nickel catalysts have lower catalytic activities for the reforming reaction of APR, and the bimagnetic catalyst with a ratio of 4:1. Ruthenium and nickel had the same catalytic activities as the ruthenium catalyst. In addition, the stability evaluation showed that the bimetanic has a higher durability than the monometanic due to the interaction between the two metals. So you can see the figure, the wrong first, wrong second, wrong third, and the bimetanic catalyst has higher stability. So the conclusion in this study, a novel two-step process in integrating hydrodermal oxidation pretreatment and catalytic APR was applied to convert waste plastic into hydrogen under male hydrodermal conditions. And during the hydrodermal oxidation process, a higher hydrogen peroxide concentration caused the over oxidation of PE produce more CO2. As bimetanic showed higher stability as compared with that the monometanic, the which offer a less catalyst operation that the noble metals. So this work was supported by the National Science Fund of the distinguished young scholar at the Innovative Research Group of the National Natural Science Foundation of China. Thank you.
Thank you very much, Hong Shai, for very interesting presentation. It's a different approach. I've never come across such research of producing hydrogen from plastic. It made me think a lot of things. So, but first I will let the audience ask you some question, and then after that I've got some questions for you. So from the audience, do you have any questions?
Yes, please.
Yes, go ahead.
Thank you, Hong Kai, for good presentation. I wish to get more understanding, please. You started with solid plastic, and after hydrothermal oxidation process, you would get the liquid and gas product.
Yes, but only the CO2. But only CO2
as a gas. Okay,
yes,
and then that liquid you use for APR.
Yes.
Okay. And your catalyst, this is not commercial one. This is the one that you developed by yourself.
This is prepared by myself.
Oh, okay. And once you tested, how long you test on APR process? Many cycle? Short term or long term?
Actually, for one experiment, I spent maybe 2 hours or 3 hours.
Okay, so have you seen something to the catalyst? Maybe deactivation or coking or nothing? Do you see any effect on your catalyst after APR?
Actually, you can see this one. This is the evaluation of the stability of the catalyst. And
did you getting decreased, right, from LUN 1 to LUN 4?
Yes.
That from the physical or chemical, from the physical appearance, your catalyst is still okay, or you have something occur to it, or? Actually,
mostly okay.
What is it? But the hydrogen yield is reducing. What is your observation? What is your idea why it's getting reduced? Because the run 1 is quite high compared to run 4.
Because it's I don't want to assist one they active and some the carbon deposition.
Oh, so you have some coating on the surface.
Yes, coating. Yes.
Okay. But is it just a light coating or is a heavy coating on the surface?
I didn't test this one.
Oh, all right. Okay.
Okay.
Don't worry. Thank you. Very, very useful information.
Thank you very much for that question. Maybe on the same line, but in an opposite direction, because this work is interesting. You're changing plastics into hydrogen, but the amount of hydrogen produced is very small as compared to a kilogram of plastic that is being decomposed, and the amount of CO2 which is generated can become a problem as well, right? Now with the same catalyst, I was just trying to connect, because the previous presenters, they were thinking about, or they were trying to share how they can recover CO2 from power plants. So has anyone explored the reverse chemical process from CO2 back to plastic? Because that will be storing the CO2 into the plastic.
Oh, this question is very
with water as an ingredient. So water, CO2.
Very good idea.
Yeah, good idea, but still needs more time.
Yes, good. Okay, so maybe you can.
You have to talk to Professor Wang for that.
Thank you.
That's good. Very interesting session. I really enjoyed the whole session. I hope the audience also enjoyed the presentations. And so that was the last presenter.
In that case, I would like to take over.
Yes.
I would like to thank the session chair, Dr. Apijit Date, and the co-chair, Dr. Thosapon Onsi, for the help with the session. I'm sure most graduate students would benefit from your discussion and advice and teaching, I'm sure. Okay, if everyone can turn on the photo, Dr. Harun would take our photo so that we can have.
This is nice to see Professor
Yes.
Date after 3 years. Professor Date,
Yes,
this
it's
is
okay.
Paul.
Professor
Paul
Paul,
Delava.
it's okay. Okay, we have almost everyone on photo. Again, I thank all the participants for this session, and hopefully you can join us again. We still have a conference day tomorrow to look up for. Hopefully you can join us and make the conference useful and fun. Hopefully everyone enjoy and getting information and from the conference. Thank you. Dr. Harun, do you have anything to add?
No, thank you very much. Thank you, Abhijit. You really, give a feedback, and it was really, enjoying. I was enjoying, like, 3 at a time. But I think you are most engaged with your audience or your presenter than other people. I really appreciate your style of, like, sharing.
I mean, I think we have to give the credit. I think we have to give the credit to the presenters and their presentations. They were very engaging. I really enjoyed.
Okay. Hopefully I'll see all of you tomorrow to help us with the conference again. Yeah. And good day and bye-bye from Thailand.
Yeah. Perfect. Thank you.
All right. Thank you.
Yeah.
Thank you.
Thank you.
Okay.
Bye-bye.
Bye.